Good morning and welcome to our second lesson on applications of quadratics. Last class, what we did was we worked on just visualizing the parabola. We spent all this time studying parabolas, learning how to graph them, learning how to solve these quadratic equations that give us points on a parabola. And we want to connect that to actual real life motion. And we're focusing on something called projectile motion, or things that are tossed or thrown. It's not the only applications that we have for quadratics, but it's probably the most common one and one of the easiest ones to get our heads around. Last class, what we did was we worked through a series of 8 task cards and just worked on picturing it, drawing a picture of it, and then labeling the vertex, the x-intercept, and the y-intercept, and associating the question in the problem with the point that we are being asked to find. So pretty much there are just 4 variations of questions that you could be asked about a quadratic application problem. And I'm going to list the categories of those questions below. So here are the different variations of questions. And really, this is just about everything. You could be asked a question about how long was the object in the air, or how far did the object go? And that would be essentially the same question depending on whether you're dealing with time or you're dealing with distance, but you're going to solve it the same way. Second kind of group of questions is how high did the object get, or when or where did the object reach its highest point? Notice that in this, we have the height of the object, the maximum height being a key point there. You could be asked what was the object's starting height, or some equivalent question. Keep in mind that there's variations on the wording here, but you would be being asked the same thing. And how high was the object at blank seconds, and you would be given an actual time. So let's take a look at our parabola. We'll put our coordinate plane on here. Here's our parabola. All right. So the question, how long was the object in the air, or how far did the object go? So keep in mind, this is some kind of object and we're throwing it. How long was the object in the air would be the question that would be asked if you had time on your x-axis. So objects in the air, objects in the air, objects in the air, objects in the, object is no longer in the air. And so this would be how long is the object in the air would be your x-intercept. The other variation is how far did the object go, or you could be asked how far away was the object. I think there's the one with the frog, and you're asked how far from the log is the frog. Something like that, how far did it go? That would be if instead of time there, you had a distance there. And so you have the frog on the log, and the frog jumps, and how far away was the frog. And so both of those questions would be x-intercept questions. Second group of questions, how high did the object get? That is, and where and when did the object reach its highest point? Both of those are vertex questions. Now there is a subtle difference. Your vertex is right there, and your vertex has an x, and your vertex has a y. How high did the object get is always going to be a y coordinate question, because this is, just think of the, if we had a coordinate plane on the whiteboard in front of, the classroom or something like that, how high it goes is always a y coordinate. This is measuring height. If we had a person standing here, okay, we want to know how tall, that's always going to be a y coordinate. Where or when did the object reach its highest height? That is an x-coordinate question. So you have the y-coordinate, which tells you how high, and the x-coordinate, which tells you when did it reach there, or where, how far away from the base of the log was it. So you might be asked for the y-coordinate of the vertex, the x-coordinate of the vertex, or both. You could be given these as 2 separate questions. So how high did the object get? I'm actually going to erase the word vertex right here. That's going to be the y-coordinate of the vertex. And where and when would be the x-coordinate of the vertex. So we have the y and the x coordinate of the vertex. So keep that in mind. How high is you're going to be looking for the y coordinate, and where or when did it reach the highest point would be the x coordinate. And both of them are going to have this like highest, the idea of how high, the maximum height. What was the object's starting height? Well, that is always going to be your y-intercept. And then how high was the object at blank seconds? And so we saw that in problem 1, like how high was the object after 1 second? Well, whatever your time is, okay, you're going to have t equals a number. Just plug that number in. Number into the equation, because that's what the equation is there for. It tells you y as a function of x, or in this case, h as a function of t. So I'm going to pause the video there for a moment and just kind of let you write this down or take a picture of it so that you're able to look at it later. Okay, so that's it. That's everything that you ever didn't know that you wanted to know about solving application problems. So yesterday I started off by drawing the pictures for the task 1 and task 4. And so what I'm going to do now is work through task 1 and task 4 so you can see how this information applies to specific problems. Okay, so refreshing our memory, we had the nephew standing on the deck, which was 4 feet off the ground, and he tosses a toy up in the air at 7 feet per second, which is irrelevant since they gave us the equation. Now, in a physics class, you would not be given the equation. You would be given that information, and then you would have to figure out the equation before you could even do anything with it. So physics is cool. So we have the equation, and notice it's h. We're using an h instead of a y, and you're using a t instead of an x, and that is just using the letter that represents what the variables represent. So y is the height, and x is the time. First question is, how high is the toy after 1 second? Well, that fits this. How high was the object at t seconds? And our strategy for doing that is to simply plug in the 1 second into the equation. So the equation gives us the height as a function of time, and we know that t is equal to 1. So I'm going to come over here, and I tried to replicate this. So for question A, t is equal to 1 second. So I'm going to go ahead and make sure that I don't slide this around. -2 times 1 squared plus 7 times 1 plus 4. Mind your order of operations here. You square before you multiply. So you're going to do 1 squared is 1, and then 1 times -2 is -2 plus 7 times 1, which is 7, plus 4. And this is 9. I believe. And we are in feet because the problem was given to us in feet per second. Yeah, the height in feet. So h is in feet. And so our answer to question A is 9 feet. And that was just a matter of plugging in the number 1. Don't make them harder than they are. Some of these are quite challenging. Some of them are really, really simple. So don't assume that a problem is super hard. Don't assume it's super easy. Take each problem as it comes. Next question is, what is the toy's maximum height? That is another way of saying how high did the object get. So what is the toy's maximum height? When you're asked for the height itself, you're being asked for the y coordinate of the vertex. So for part B, we are going to need to find the vertex. So here's our equation, h equals -2t squared plus 7t plus 4. And remember our formula for finding the vertex. X is equal to the opposite of B over 2A. Now, in this problem, we're not using an X, we're using a T. So I'm going to go ahead and just rewrite that as T is equal to the opposite of B over 2A. So T is equal to the opposite of B. Well, B is 7. So the opposite of 7 would be -7 over 2 times A, which is -2. And we get negative 7 over negative 4. A negative divided by a negative is a positive, and 7 divided by 4 is 1.75 seconds. Now let's go back and make sure we are looking at the question the right way. The question was, what is the toy's maximum height? Well, we haven't found the toy's maximum height, and make sure that your brain is engaged with this. What I have here is 1.75. So please don't tell me 1.75 is the toy's maximum height, because in the previous problem, we found the height of the toy to be 9 feet. So it at least goes up to 9 feet. It's not 1.75. So make sure that you're always thinking about your answer and whether your answer is reasonable. So what did we find? What is the 1.75? Well, what we found was the x coordinate of the vertex. And basically what that means is that the toy hits the maximum height at 1.75 seconds. So at 1 second, it's gone up 9 feet, but it's going to continue to go up. And at 1.75 seconds, that's when the toy hits the maximum height. But we weren't asked for when the toy hits the maximum height. We were asked what is the maximum height, which means we need the y coordinate, or in this case, the h coordinate. So we're going to take the 1.75, plug it in for t, and that's going to give us the height at 1.75 seconds. So I'm going to go ahead and plug that in. And I would strongly recommend using a calculator to do this, which I don't have in the room where I am at. So I'm going to pause the video and go grab a calculator, because I don't want to do that out by hand any more than you do. And you want to try to enter it into your calculator in one step. We want to make our lives easy. And so what do? I hit the wrong button there. So the height is equal to 10.125 feet. And that does make sense. So we want to make sure that we're still thinking about the problem and we're not checked out when it comes to solving the problem, whether the answers make sense. So at 9 seconds, at 1 second, the ball was 9 feet high. So after 1 second went by, so at 1 second, the ball was 9 feet high, but after another 3/4 of a second go by, the ball is up higher. The ball is at 10.125. And so that should make sense. And if you need to pause the video to just kind of make sure those numbers are making sense to you, please do. So the maximum height was 10.125 feet. Now, the last question there is, how long is the toy in the air? Well, the toy is in the air, 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 not in the air. Right here is where it is no longer in the air. This is the x-intercept, and what's important to remember about that is that y is equal to 0. Or in this case, the height is equal to 0. So I'm going to trace that one more time on this picture. Height is 9 feet. Height is 10.125 feet. Height is decreasing. The height is decreasing. The height is decreasing. And at the moment the ball or the toy is no longer in the air, the height is 0. So looking at our equation, we know that when the ball is no longer I don't know why I keep saying it's a ball. It's just a toy. It's actually a teddy bear in the little task card. So go figure. When the teddy bear is no longer in the air, the height is 0. And what we have here is what we've been working on for a while. We have a quadratic equation. It is set equal to 0. I believe that all of the quadratics in this activity are factorable, meaning that you can solve these by finding the factors. If you don't want to factor them, you are welcome to solve them some other way, probably using the quadratic formula. That I am not going to dictate for you, because once we get into the realm of applications, then it's just important that you can solve it. But I believe they are all factorable. So I'm going to go ahead and start with slide and divide. We're going to slide that -2 down. -2 times 4 is -8. Then we'll factor this. We want two numbers that multiply to -8 but add up to +7, and that would be a +8 and a -1. Make sure you divide and then simplify your fractions. So this becomes t minus 4, and this becomes -2t minus 1. You can also simplify this to get a +1/2 there. That would also work. So you'd have a +2 and a +1, and that should work. I gotta think about it, like the sign at the end, but I'm just gonna go ahead and slide the -2 back. Now we would set each one of those factors equal to 0, so we get t is equal to 4, and here we're gonna add 1 to both sides, and then divide both sides by -2, and I'm actually going to change it to a decimal because when we're dealing with word problems, we probably do want the decimal. Now, notice that we have two answers to this. We have 4 seconds and we have -1/2 seconds. So let's make sure we can interpret what those mean. In our picture here, it does make sense that the toy would hit the ground after 4 seconds. So it comes up, it hits its maximum height at around the halfway point. The reason it's not perfectly halfway is because it started 4 feet off the ground. And then it comes and it hits the ground 4 seconds later. The -1/2 is actually this spot. It's actually back here. It's a solution to the equation because the parabola does have another x-intercept, but it doesn't mean anything in this problem. The answer we want is the +4. And so how long is the toy in the air? 4 seconds. Notice that I did go through that fairly quickly, and that's because we spent a ton of time on factoring, and we spent a lot of time on solving the quadratics. So by the time we get to this spot, like the assumption is that I should not have to keep reteaching the old skills, that you have practiced them enough that you have them. Let's take a look at task card number 4. So this is the one that had the carnival attraction, testing your weight. So you're going to bang the hammer down and it's going to go up and then come back down. And we were asked 3 questions. How long is the weight moving? What is the weight's maximum height? And did you win a prize? So we want to go back to your picture, and hopefully your pictures are all still in your activity from yesterday so that you'll be able to see it. Like, most of us are visual learners. Most of us make sense of things when we see it, which is why if your eyes are on your phone instead of on the notes, it becomes a hindrance to you being able to learn because you need to be able to see what's happening. The words I'm saying and the things I'm writing need to match up. So what we have here is the weight. The weight goes up and then it comes down. We are measuring this in time, and then this is the height. So as time goes by, the weight goes higher and then it comes back down again. First question was, how long is the weight moving? And we established, we hope yesterday, that that's going to be the x-intercept. So it's going to be this down here. Now, make sure you're reasoning, okay? We don't want to just memorize steps. We want to be able to process and make sense of the problem. When the weight comes back down, the height is 0. So here is the height. Height is 0 right here. And so the way we're going to figure out what the x-intercept is we are actually going to plug in height is equal to 0. So here's the equation, and remember, to figure out the x-intercept, we're going to use height is equal to 0, and immediately that is what we've been doing. That's solving our equations. Like I said, I believe all of these are factorable, but if you're looking at this and the numbers look a little bit too big for you, you are welcome to use the quadratic formula. I'm going to go through and factor it though. So we're going to slide the -16 down. And that'll give us t squared plus 31t. -16 times +2 is -32. And then we will break that up. And I'm looking for 2 factors of -32 that add up to +31. That's going to be +32 and -1. And then make sure that you do divide out whatever it was that you multiplied by. Here in the left-hand factor, 32 divided by negative 16 is negative 2. And on the right-hand factor, I'm going to go ahead and slide the negative 16 back. And we set each factor equal to 0. That's our zero product property. Add 2 to both sides, so I get 2 seconds as one of the answers. And you might even at this point, that's negative 16t, add 1 to both sides, and then divide both sides by negative 16. And I'm going to do that on my calculator. Negative 0.0625 seconds. And those are the two numbers. But keep it in context of the problem. Okay, the only one that actually makes sense here is this one. This is the number we're looking for. So we're looking for the 2 seconds, not the negative one that's going to be just in back there. Okay, that's not the one that we want. So we're going to take the t equals 2 seconds. So how long was the weight moving? The weight was moving for 2 seconds. Second question, what was the weight's maximum height? So looking at our picture, the maximum height is going to be the vertex. And remember that there are 2 questions you could be asked. You could be asked, what is the maximum height? In which case you're looking for the y coordinate. You could also be asked, when did it reach the maximum height, or how long did it take to reach the maximum height? And that's going to be the x coordinate. And that might take a couple tries to straighten out, like which one am I looking for, the x or the y. But if it's a where or when, it's an x coordinate. If it's a what, it's a y coordinate. We are being asked what, so we are looking for the y coordinate of the vertex. Here's our formula, and remember the x coordinate is the opposite of b over 2a, but we're using t here, so the t, or the time when it hits the maximum height, we're going to find doing opposite of b over 2a. So in this case, the opposite of 31 is negative 31 over 2 times a, which is negative 16. So this is negative 31 over negative 32. And I'm going to go ahead and divide that on my calculator. And I get this. I get 0.96875 seconds. Remember, that is time, okay? Because it's t. It's time. That's not the maximum height of the weight. That is how long it took the weight to get up as high as it did. So a little bit less than a second. It gets up to about here, or maybe it does ring the bell. We don't know. But it takes a little bit less than a second for the weight to get that high. The question we're asked is, what is that height? So how high did it get? We're going to take that number, lovely number, and plug it in for the time, and that will give us the height. So the height is negative 16 times 0.96875 all squared plus 31 times 0.96875 plus 2. And we're going to dump that into our calculator. So I'm like literally doing that right now because I don't have the answer in front of me. Make sure that you get your order of operations correct. So you're not multiplying before you, no, I can't talk and enter stuff in because I just did it wrong. 96875, there we go. Plus 2. And I get a height of 17.0, we'll say 17.02 feet. Okay, so I'm going to come back over here. Now, this is when it hits the maximum height, and this is what the maximum height is. So x coordinate, y coordinate. And so this is about 7. Now, this, what is the weight's maximum height? I'm going to put in the 17.02 feet. But then I'm actually going to do this. I'm going to say 15 feet. And the reason I'm doing that, I'm going to give both answers, okay, is because the way this carnival attraction is set up, it's not going to be able to go 17 feet. It's going to go up the 15 feet. It's going to ring the bell, and then it's going to drop back down. So I'm going to put the calculated value there, and then I'm going to acknowledge the context of the word problem, which says that it really can only go 15 feet. Last question there is, did you win a prize, and how do you know? Well, we do know that we won a prize, and then make sure you answer the how do you know, because it reached 15 feet. Okay, that's all I'm going to say, because it reached the 15 feet, and that's what it needed to reach. If it reaches 15 feet, you win a prize, and ours went higher than that, or it would have gone higher if a ride had allowed it. So what your task is in your group, you have 6 more problems. Now I've done these 2, and I do expect you to copy down the solutions that I've done for you. So hopefully you've been taking notes, but you can go back and play the video again if you need to, or rework the problems for practice. That's also a good idea. In your groups, you're going to do this for the remaining 6 problems. I would encourage you to divide and conquer, but then collaborate. So don't assume that your neighbor or your group mate is doing a problem right. Go take a look at their work, and if you think you see a mistake, you want to address it in a polite, respectful, encouraging way, because that's how all of us like to be treated. And then just kind of confirm, and if you're not sure, ask your group mates, am I looking for the X or the Y coordinate of the vertex? You have 6 additional problems to do, and you have the remaining class time today and all of the class time tomorrow to work together as a group. And then if it's still not done, then it will become your homework for tomorrow night. But there's no more instruction on that. You just need some time to work on it, but you should have plenty of time to do 6 additional problems. And that completes our last lesson for this unit. Once we finish all these problems, then we will be gearing up for your test.